All right, so now that we know how to put our numbers into scientific notation, what we need to start to use is a metric system so that we can express our really large numbers and really small numbers in one system and then convert in between our different notations. Okay, so in chemistry, right, we measure matter using SI units, right? So this is an abbreviation for Standard International right? It's French. Really, it's the international standard that we use, okay? So, in SI, in metric units, right, we use SI base units, okay? So all of these are our base units, okay? First off, we have our meter. This is, of course, a measure of length. Then G is for a gram, and this is for mass. PA is a Pascal, and this is for pressure. We're not going to use this too much. We'll actually use different units for pressure, but it is the SI base unit. K is for Kelvin, and we will use the Kelvin scale when we're looking at our temperatures later in the year. Mole is mole. I don't know if it really saves us much, but MOL versus MOLE. This is an amount. We'll talk a whole lot more about the mole because chemists use the mole all the time. J is for joule. We've talked about how joules is how we are going to start measuring our energy. S is for second. This is our SI unit for time. L is for liter. You can spell it the British way or the English way. And this is, of course, for a volume. ppm is parts per million. And this is not SI. But ppm is a way that we measure concentration that we oftentimes see just in the real world. Instead, when we're measuring concentration, we use molar, which is this big M. And we will talk a whole lot more about that later in the year. Okay, so what we're going to start to see is that we have a base unit, like the ones that we just went through, and then we are going to see a prefix, okay? So a prefix, we're going to see any of these symbols, and then we're going to have a base unit. You'll notice, right, one of the ones that oftentimes confuses people is that M here as a prefix is for milli, and then we could have M, which is for a meter, which is the base unit. Okay, so what we will see when we see our symbols, we will have the prefix first, and then the base unit. So here's a list of our prefixes, and then we've got more prefixes down here. Okay, so we can go tera, giga, mega, kilo, hecto, deca, no prefix at all, deci, centi, milli, micro, nano, pico, femto, atto. So we can get really small and we can get really big, okay? And you'll notice that our exponents here, we have essentially our scientific notation on here, okay? Something that we're going to have to correct, we've got some numbers down here that got a little messed up by the table, okay? So first off, our symbol for micro is not a square. It is this mu, which kind of looks like a weird M, kind of like a weird U, and that's for micro, okay? It's the Greek letter mu. And then our pico is 10 to the minus 12th, femto is 10 to the minus 15th, and then atto is 10 to the minus 18th, okay? And then I think we've got all of our exponents fixed, we've got our symbols fixed. So what we're going to have to start to do is convert between like terameter and a meter, something like that, okay? So our ways to convert, right? What we're going to do is we're going to start using conversion factors, okay? So it's a mathematical expression that relates two units that measure the same type of quantity, right? So this would be like grams going to kilograms, or we could do millimeters going to decameters, something like that, okay? So usually the most that we're going to have to convert between is going to be between kilo and milli, okay? That's about as far as we go, but we actually are going to start with going a little bit further, okay, into some of our more obscure prefixes, okay? So this is always just a matter of moving the decimal. All right, so first you must also make sure that you move the decimal in the right direction. Okay, so if we have kilo going to milli, we have to make sure that we convert in the right direction. Okay, so we have to move the decimal in the direction that we're going. So what we are doing here, we've got our base unit, right? This would be like a meter. And we can, maybe we're going from meters to millimeters. We want to move the decimal to the right to get our millimeter, okay? So an example here, right? Say we have 1,000 meters. 1,000 meters, if I wanted to convert it over to millimeters, what I'm going to have to do is move it 1, 2, 3 decimals. So 1,000 meters, I'll go 1,000. I'm going to move it 1, 2, 3 spots over to here, and now I've got 1,000,000 millimeters, okay? If I wanted to go from 1,000 meters over to kilometers, what I would do, right, I would start with my 1,000 again. I'm going to move it over 1, 2, 3 spots. 1, 2, 3 spots. I've got 1 kilometer, okay? So it's really important that we look for this prefix and then we look at the base unit, okay? We need to identify our base unit and then figure out the prefix, okay? So let's do some practice down here, all right? Car travels 840 kilometers. How many meters is this, right? I'm going to start with my 845 kilometers, and I'm going to move it to the right to get to meters. I'm going to move it 1, 2, 3 spots. So 3 decimals. I'm going to remember that. So 845. I'm going to move 1, 2, 3, and then put my zeros in, and then I'm going to put my unit on there. So 845,000 meters. Okay? Convert 0.0290 liters to milliliters. So again, same idea. I've got my liters, 0.0290 liters, and I'm going to convert it 3 decimal places because my base unit here is liters. So my base unit is liters. I'm going to go 1, 2, 3 over to milliliters. Okay? Is 3 decimals. Okay, so I'm going to go 0.02 or 0. I'm going to cross that out. I messed up. 0.0290 liters. I'm going to move it over 1, 2, 3 decimal spots. So 0, 0, 0. Oh, whoa! I screwed up already. I'm going to redo that again. 0.0290 My decimal is over here, so I'm going to go 1, 2, 3 decimal spots there. So now my 0.0290 liters is 29 milliliters. Okay? Keep on going. We can do all of these down here, and then we have to check our answer. Okay? We can always check our answer because we know that milliliters is smaller than liters, so I should have more milliliters than liters, right? When I had 0.029 liters, when I moved it, I converted it to milliliters, I should have a higher number because I moved my decimal to the right, okay?